Okay, so we're going to run the model for a range of k values, and then we're going to find the prediction, and from the confusion matrix we will get the accuracy and build a data frame. Okay, for k equal to 1, what is the accuracy? For k equal to 2, what is the accuracy? And so on, right? So to do that, we have to first set up, initialize the data frame where we will be saving the accuracy value. Okay, so we'll call that knn dot accuracy, right? So that is data frame called k equal to a vector 1 to 20. So this will populate the first column. We will call, the first column's name is going to be k, and it's going to have values 1, 2, 3 up to 20. Okay. And then we are only initializing the data frame, so the next column, we'll just populate it with zeros for the present. Okay, so it's going to be accuracy. We'll call so we'll name the column as accuracy, and then we're going to populate it with a rep here is repeat. Repeat 0 how many times? Okay, 20 times. So you'll have first column k, the numbers, you have 1, 2, 3 up to 20. The second column is going to be called accuracy. It will all have 0. Okay. So now if you look at knn accuracy, so there you have it. Okay, so you've set up the data frame where you will save the accuracies as you compute. Okay. There is one other thing that we're going to do, and that is normalize data. Okay, this is very important, because distance, you're measuring the distance by subtracting the pairwise x values, right? So if a given column has large values, then that squared value is going to be really high, as opposed to another column. So you have salary in the tens of thousands. Okay, and then you have age, which is like what, 25 to 75 or something. So the differences in salaries is going to be in the tens of thousands. The differences in age is going to be in the tens. So this salary column is going to overwhelm the other columns. That's going to dominate the distance. So whichever has the closest salary value, that's going to be the one that you will end up selecting. So your salary is going to dominate everything else, and you don't want that. You want the playing field to be level. So that's the reason why it is very important to normalize in k and n methods. Okay, it's important in other methods also, but not so important in some, like naive or decision tree is not important. You don't have to normalize. Okay, but here it is extremely important. It's the opposite of decision tree. So how do you normalize? There are several ways to normalize. Okay, so we have what is called pre-process. It's part of Caret. Okay, so let's call it train norm. Okay, and well, no, not train. We have to set up the formula for normalizing. Okay, so we're going to call that BH normalize. Okay, and we're going to use pre-process. Okay, so remember, pre-process is part of Caret. So now you say, okay, what do you want to pre-process? Okay. The data that we want to pre-process is train.df. Okay, so that is the source which is going to be used to calculate the formulas for normalizing. Okay, and there's a bunch of normalizing that we can do. Okay, so we're going to do a z-scale normalization. So z-scale normalization is what? You subtract mean from each value and divide by the standard deviation. So that is called, so you want train, but we don't want to, okay, we don't want to normalize the cat met v. Cat met v is the target. So all columns except the target and the method we want to use. Okay, so you have to specify the method as a vector. Okay, there are, as I said, there are a lot of methods, and okay, range is one method. Okay, if you say range, then range normalization will happen. Okay, range normalization is what? Subtract from each observation, subtract min, and then divide by the range. Okay, but if you want standard deviation normalization or z-scale normalization, then you say center. So center is going to center. That means you're going to subtract the mean. From each observation, you'll subtract the mean. So that's your center. Okay. And then you have to say scale. Okay, scale is divide by, so you're doing two things here. Subtracting the mean, and then after that, you divide that by standard deviation. Okay, so this is going to find the center for each column. It will find the standard deviation for each column, and then so train dot norm. Okay. So you use the predict method, right? So the first argument for predict method is the model that we're going to use for the normalization. Okay, and that is in bh.normalize. That's where all the information that we need for normalization is stored. And then you specify the data that needs to be normalized. So that in this case is going to be train.df. Okay. And you need to do the same for valid also. So valid.norm is going to be predict. Okay, so you're going to use the same formulas, but then instead of train.df, you will have valid.df. So this is going to normalize our data. Okay. So if you go into so valid norm, okay, you see everything is normalized now between approximately -3 to +3. And then train.norm, again the same thing. Okay. Now we have the data prepared, and we have the data frame where we're going to store the accuracies prepared. So now we have to run the KNN model for each of the k's, k equal to 1, k equal to 2, and so on. Okay. We will do that next time.